All right, we've got one more gravity problem that we're going to look at, number 17 here. And so here we've got a planet orbiting a star. It doesn't give us a whole lot of information other than at one point it's moved in the satellite's, the planet's orbit around the star, it's moving at 1,200 meters per second, and at some other point it's moving at 800 meters per second. And so there's a question, how much work is done by gravity as the planet, on the planet, as the planet moves from the first point to the second point? And we're actually going to answer this question not really with any calculation. We're going to answer with our work energy equation. Let's take a look at our work energy equation here. Okay. Now, as a planet moves along its trajectory here, as it moves along its trajectory, the only force acting on it is going to be the force of gravity, and so there isn't going to be any non-conservative forces. This is going to be zero here. And so, right away we can get some, we can get qualitatively a result that's going to be very helpful for us. If we consider the initial point to be point P, and this planet moves out to point Q, that will be our final point. And what do we see here? The final kinetic energy is going to be less than the initial kinetic energy because it has a slower speed here. The planet has a slower speed. So if the kinetic energy has decreased as it goes from point P to Q, that means that the potential energy, the gravitational potential energy, has increased. Potential energy has increased. Or in other words, the change in gravitational potential energy is going to be greater than zero, positive. Potential energy increases as the object goes from point P to point Q. And that's essentially all we need because we know the definition of potential energy. We know the definition of a potential energy. So for gravitational potential energy, here's the definition of gravitational potential energy. And so if this right here is positive, we've got a negative sign here, that means the work done by gravity is negative. The answer would be